Missed few parts in the recording.
Yeah.
Because now it is turned off.
Okay, I have started recording.
We missed only 2 minutes of recording, right?
Yeah. The next IoT life cycle. Then within the IoT life cycle, yeah, it's started.
Okay.
Then in the IoT life cycle, first we have to collect the data. අපිට පළවෙනි option එක විදියට data collect කරගන්න ඕනේ. Then for the collecting data, we can use sensors. Then most of the time we are using sensors to collect data. Then we can use many type of sensors. This is one of the example. Within here, there are some water level sensors. That's a very simple sensor. Then by using that water level sensor, we can measure the water level of the tank. Then many different technologies we are using with that sensor. Like we can use some pressure sensor, or we can use some water detecting sensor, or many different technologies we are using for detecting water level. Commonly, we can use that as a water level detecting sensor. Then first they have to detect water levels. Then it's in between upper threshold level and lower threshold value. Then the minimum level is lower value, lower threshold value. අපි හිතමු මේක අඩුම level එක තියෙනවා කියලා. අඩුම level එක කියන්නේ lower threshold value එක. Lower threshold value එක කියලා අපි කියනවා. ඒතකොට lower threshold value එකට වඩා අඩු වුණොත් water level එක, they can automatically give some message. And they can automatically switch on motor, or they can automatically switch on some water pumping system. And same as the after that water filling with the time period. Then after half an hour, after within 1 year, it will fill water. අපි හිතමු පැය භාගයකදී නැත්නම් පැයකදී මේක සම්පූර්ණ පිරෙනවා. Then if it is going to the upper threshold value, අපි කියන overflow level එක. Then if it is going to the overflow level, then we have to stop that mechanism. අපිට එනම් අර water fill වෙන level එක stop කරන්න ඕනේ. Then that done by this system. System එකෙන් automatically මේක වෙනවා. That's the first steps. අපි කියන මේකට collected data. First data collect වෙනවා. Then after that collected data, they have to send for central device. අපි කියනවා central database එකට මේ ටික send කරන්න ඕනේ. Send කරන්න they can use some of the mechanism. මොකක්ද එහෙනම් අපිට පාවිච්චි කරන්න පුළුවන් data ටික send කරන්න. We can use internet for sharing that data. Like we can use some of the GSM, then 4G, 3G, like that many GSM network, Wi-Fi network, or like that many different type of network we can use for sharing data. Data ටික share කරන්න පුළුවන් මේ විදිහට අපිට second step එක විදිහට. After that shared data we have to keep in somewhere. අපි දැන් data ටික collect කරගත්තා. ඒ ටික over the internet share කළා. මේ share කරගත්තු data ටික අපි කොහොමද store කරගන්නේ? Then we can use some of the computer or server computer for that. Then with the time period අපි හිතමු within 1 day එක දවසක් ඇතුළත අපි data ටික collect කරනවා. Okay. Give me 1 minute. Okay, then okay, yeah. Then next we have to analyze that collected data. අපි data එක collect කරගත්තා. Then next we have to analyze it. Then analyzing means we can keep some of the collected data in server computer. And most of the time we are using server computer for that. Or if you haven't server computer, then we can use mobile phone also for collecting data. අපිට මේ data ටික mobile phone එකකට collect කරගන්නත් පුළුවන්. And after that we can analyze it. අපිට එන data ටික analyze කරන්න පුළුවන්. That's the third condition. First we have to collect data, then we have to transmit data to the server system. After that we have to analyze it. So analyze කළාම අපිට බලන්න පුළුවන් දවසකට කී සැරයක් මේ water tank එක overflow level එකට පිරලා තියෙනවා. like අපිට we can decide it. අපිට පුළුවන් මේ tank එකේ වතුර කොච්චර අඩු වෙන ප්‍රමාණය දවසකට කී සැරයක් tank එක අඩු වුණාද? We have to check it now. Then same as the අපි කී සැරයක් වතුර මෝටරේ on කරන්න සිද්ධ වුණාද? Within some of the organization අපි හිතමු ලොකු company එකක කියලා. ලොකු organization එකක like within your school. ස්කෝල් එක කියලා අපි හිතමු. ඒතර ස්කෝලේ තියෙන වතුර ටැංක් එක දවසට කී සැරයක් වතුර fill කරන්න ඕනද? Then we can identify that sequence. Then we can identify that sequence and finally we can take some decision. එහෙනම් අපිට ඊළඟ දවසේ දවසට කී සැරයක් මේක on කරන්න ඕනද කියලා decision එකක් ගන්න පුළුවන්. Like that. We can take some actions. Previous data ටික use කරලා අපිට analyze කරලා we can take some decision. That's the advantage. That's a simple example එකක් මම ගත්තේ. මේක අපිට apply කරන්න පුළුවන් water tank එකකට විතරක් නෙවෙයි එදිනෙදා අපේ life එකේ ඕනම තැනකට. අපි හිතමු අපේ පන්ති කාමරය කියලා. In your class environment. Then you have to detect something. Like their temperature. Or in your home environment you have to detect temperature. Then you can use some of the temperature sensor. And with the time period, like a half an hour, within half an hour, you have to collect some data. අපි දෙමු පැය භාගයට අපි temperature එක detect කරනවා. And within one day, we can get the all data, all temperature data. දවසේ පැය 24 ඇතුළත තියෙන සම්පූර්ණ temperature data ටික අපිට මේ විදිහට collect කරගන්න පුළුවන්. And we can analyze it. Analyze කළා අපිට එහෙනම් ඊළඟ දවසේ decision එක ගන්න පුළුවන් මෙන්න මේ විදිහට තමයි temperature එක change වෙන්නේ. Like that. උදාහරණයක් විදිහට ගත්තොත් it's a simple example like a weather condition එක. Within Sri Lanka also there like they will detect weather condition and they will give some suggestions. ඒගොල්ලෝ analyze කළා within first they are collecting data and they will analyze it. After that they will give some message. උදාහරණයක් විදිහට ගත්තොත් it's a very simple වහින්න පැය භාගයට කලින් they can give some message for their users. No, before the raining they can give some messages. Then users they can give that as advantage. අපිට කුඩේ අරන් යන්න අමතක වුණා නම් then we can take it. Otherwise we can plan our future thing according to the weather condition. අපි මොනවා හරි organize කරනවා නම් like event එකක් අපි හිතමු within next day we have to organize some event. Then first we can check the weather condition and after that we can identify that. Like that we can do it. මම මේ කතා කළේ අපි පාවිච්චි කරන IoT life cycle එක ගැන. We can do like that life cycle. Yeah, I think all of you can see presentation. Okay. Then we are discussing about the life cycle of the IoT system. That's a theory base. I think most of the students, they have to write down some theory questions in the A-level exam. Then I think this one help for that. And next we are discussing about what are the advantage in IoT technology. If you are using that IoT technology, then which kind of advantage you can get. The first one is we can apply that IoT technology for everywhere. Anywhere we can apply it. And anytime. ඕන වෙලාවක අපිට මේක use කරන්න පුළුවන්. And ඕන time මේක ඕන තැනක අපිට apply කරන්න පුළුවන්. That's the one thing. Then as same as we can transferring some data over the internet connectivity. අපි කියනවා IoT කියලා. Then over the internet we can transfer that data. That's the advantage. Then one of the embedded system there, අපි කියන embedded circuit එක design කරලා, then we can capture some data and we can transfer that over the internet connectivity. අපිට mobile phone එකට එහෙම නැත්නම් අපේ server computer එකට, අපේ personal computer එකට we can transferring that. That's the advantage. And same as we can apply that for many different places, many different things. For the education, for the hospitality, for the home environment, like that. For the any environment, we can apply that. Same as the indoor and outdoor also. අපිට ගෙදර ඇතුලේ තියෙන system එකකට පාවිච්චි කරන්න පුළුවන්. ඕක ගෙදර එළියේ තියෙන system එකකට පාවිච්චි කරන්න පුළුවන්. Like that. Normally we can use that for the gate entrance of the home, or we can apply that for the entrance of the school. Like that. For the if you need to take some attendance, අපිට මේ school attendance ගන්න ඕන. Then we can apply some IoT systems for that. Very simple IoT system we can prepare and we can collect attendance. And we can keep that attendance in mobile phone or in the computer. Then in the school, we can collect all the student attendance, like there are different classes now. Then class 1 to all the classes, we can collect attendance, all the attendance, and we can keep that in one computer. Then if teachers, they need to collect attendance of some students, it's very easy to analyze it. අපිට දුම් මාසක attendance ගන්න ඕනේ නැත්නම් එක වාරක attendance ගන්න ඕනේ, then we can collect it and we can analyze quickly. And same as the next one is we can minimize human effort. As a simple example, අපි හිතමු ඉස්කෝලේ attendance ගන්න ඕනේ. Then the teacher හැමදාම උදේට attendance mark කරන්න ඕනේ for the class. In every class they need to mark manually. But if you maintain that IoT attendance system, then no need to that. Student class එකට එද්දී අපිට පුළුවන් එයාගේ finger එක තියාගෙන ඉන්න කියන්න. Like that. Then we can make some embedded system in the entrance of the school or entrance of the class. අතට ඇතුළට එද්දී හැමෝගෙම finger mark එක තියාගෙන ඉන්න. Then within months period or within weeks period, they can identify their attendance. අපිට cost එක reduce කරගන්න පුළුවන්. Same as the human effort එක reduce කරගන්න පුළුවන්. Data forget වෙන එක, එහෙම නැත්නම් data duplicate වෙන එක අඩු කරගන්න පුළුවන්. Like that many advantage there. And next one is the low power consumption. Power usage එක අඩුයි. Then we can use very simple and very small sensors for that. Then they are using very small power. Like we can use some of the solar power, or we can use some of the battery power. If we are using solar power, then a long time we can use it without main current. Like that many advantage there. And same as the security. Security is very high if we are using IoT system. As a simple example, අපි හිතමු attendance කියලා. අපි ඉස්කෝලේ attendance mark කරන්න ඕනේ students ලගේ. Then normally we are using attendance sheet. But after that, after collecting that attendance, we are keeping it somewhere. Then some other person, they can access it. But if we are collected that via the IoT system, then that data can access only the administrator. Because of other persons, they can't access that attendance. Like that advantage also there. That's a many advantage. Like that many advantage there in IoT systems. Yeah. Can you hear me? Yeah. Okay. Then this is the IoT applications. Then the first image. This is a simple IoT robot system. අපි ගත්තොත් මේ තියෙන සරල IoT robot system එකක්. Then we can control that robot car system over the mobile phone. It's very simple. We can prepare a very small robot car like that, and we can control that over the internet from your mobile. It's very simple thing, and within very small robot you can control and you can prepare a very small robot system like that, and you can apply for many conditions. අපිට මේක ගොඩක් තැන් වලට apply කරන්න පුළුවන්. That's the advantage. Then same as the last one. Then the last one is the robot doctor. Then there is some machine like a robot system. Then doctor, they can log into the robot system, and after that at robot system they can control, they can move, and doctor, they can contact with the patient, and patient එක කතා කරන්න පුළුවන්, their conditions check කරන්න පුළුවන්, like that. There is some camera, mics, and all the settings there. Then directly they can contact, time to time they can contact, but doctor, they no need to go to that place. And we think doctor is in their office, but they can connect multiple robot system like that. එක hospital එකක තියෙන එක hospital එකක ඉන්න patients like නෙවෙයි, කියන්නේ multiple access කරන්න පුළුවන්. අපි හිතමු එක doctor කෙනෙක් එකම time එකකට patients ලා 10 දෙනෙක් බලන්න ඕන. Then they can log into the same system and they can do it. It's very simple. And same as the next one is nowadays available. This one is the pharmacy and some of the supermarket system. Then in the supermarket, there's some robot system, IoT system. Then first you can insert what's the list you need to buy. What කරගන්න ඕන item list එක ඔයාලට enter කරන්න පුළුවන් මේ තියෙන robot system එකට. Then they can find the location in the supermarket and they will give some help for you. අපිට ගිහිලා රාක්ක වල හැමතැන හොයන්න ඕනේ නැහැ. They will direct it. එහෙනම් ඉතා සරල simple විදිහට අපිට data ගන්න පුළුවන් මේ වගේ. That's one of the other example. The next one is the another example like that. We can apply that robot technology many more things. And same as the self-driving car also there. Then self-driving car there. Then without driver, they can control. It's very simple. And most of the time inside the some organization, there are some robot system to handle internal thing. Then most of the time, like within some of the factory, they have to move something in some location to some other location. Then they can use that some of the robot technology or IoT technology for that. Over the internet, supervisor, they can view it. That's the advantage. I think you are clear that. These are the very few simple examples, but there are so many examples you can search in Google and you can search it. Then next, when you are preparing like that robot system, then which type of devices we can use? As a simple, we can use computer. අපිට computer එකක් පාවිච්චි කරන්න පුළුවන් මේ device එක විදියට. But computer is very expensive and we need more power for that. Because of that, we can use very simple equipment. We are telling that as a microcontroller. We can use microcontroller for that. Then a microcontroller means inside the inside this controlling board, there's a microcontroller. Then it's like that, very small IC. අපි කියන මේ microcontroller කියන IC එක. Integrated circuit එක. It's an integrated circuit. We can program it. That's the advantage. Then there are many different kind of ICs there, but this one is programmable IC. Then where we can apply it? කොහෙද මේ programmable ICs තියෙන්නේ? I think all of you know, in your home environment, you are using washing machine and you are using TV, fridge, and some of the smart items like a CCTV camera, like that many smart items there in your home environment. Then inside that item, there are some microcontroller, like that microcontrollers there. Then first they are using that microcontroller and they are write down some programs according to the different purpose. Like within your fridge, smart fridge, there's some microcontroller. Then same as within your TV, and same as the nowadays routers, they are using routers. Then inside the router there is a microchip. Like that, we are using microcontroller for many different applications. And why we are using microcontroller? ඇයි අපි මේ microcontrollers එනම් පාවිච්චි කරන්නේ? We have to identify that. Then a microcontroller is, it's a small computer. අපි කියන මේ microcontroller කියන්නේ it's very small computer. It's like a computer. Then what are the things available in computer? I think as a IT student, you know what are the included parts inside the computer. It's including some of the memory and same as the processor. අනිවාර්යෙන් processor එකක් තිබිය යුතුමයි. Then they have to do some process, no? And same as there are some RAM, ROM, flash memory. Then what are the input output devices? Like that, many different kind of thing are there inside the computer. Then same as this microcontroller is equal to the smaller computer. My microcontroller ඇතුලේ including small CPU, central processing unit එකක් තියෙනවා. Then the same as there are some RAM. Small RAM unit is there. Then small ROM unit is there. RAM එකක් තියෙනවා, ROM එකක් තියෙනවා. And there is some flash memory. Flash memory means then we have to write down some program, no? Then inside our computer there is some hard disk. Computer එක use කරන hard disk එකක් for saving data. But microcontroller එකට අපිට hard disk එකක් use කරන්න බෑ. We are using flash memory for that, like your pen drive. And the same as we can use many more internal devices in there. And same as we can connect many input and output devices to the microcontroller. Then what's the main difference in between microcontroller and computer? මම කලින් කිව්වා computer එකක් සහ microcontroller එකක් සමානයි කියලා. But there are some differences. මේ දෙකේ වෙනස්කම්නුත් තියෙනවා. Then a computer we are using for not only one task. While the computer we can do many tasks. අපිට වැඩ ගොඩක් කරන්න පුළුවන්. We can play some music, we can open some of the web pages, and we can do documentation, we can do many things now. Same as the but microcontroller we are not using for that. අපි microcontroller එක පාවිච්චි කරන්නේ only for one task. If you need to detect some of the temperature, then you can use microcontroller. And if you need to detect some of the pressure level or gas leakage, then you can use microcontroller. Like everything, as a simple example, your fridge. Fridge එකේ මොනවා හරි එක purpose එකක් නේ කරන්නේ. Then same as the TV. Inside the TV, we are using one purpose. Then same as the that kind of devices, we are using for only one task. මේක පාවිච්චි කළාත් එක වැඩක් තමයි කරන්නේ. But computer we are using for many different purpose. That's the main difference in between microcontroller and computer. Otherwise, it's like a small computer. Then these are the simple examples for the microcontroller. There are some different families. අපි කියනවා එක එක brands තියෙනවා. Then pick microcontroller brands, Atmel microcontroller brands, Intel microcontroller brands, same as the Epson microcontroller bands. Like that, many different microcontroller bands there. Manufacture අනුව මේ වර්ග වෙනස් වෙනවා. Next, we will do that for the practical. අපි practical වලදී මේ ටික පාවිච්චි කරන විදිහ මම කියලා දෙන්නම්. But now first we have to identify their theory. Then when you are taking microcontroller, it's like that. අපි microcontroller මෙන්න මේ වගේ තමයි තියෙන්නේ. It's like a 20 pin microcontroller there, then a 16 pin, 100 pin, 200 pin, like that. Different microcontrollers there for different purpose. එක එක වැඩ කරගන්න අපිට විවිධාකාර microcontroller use කරන්න පුළුවන්. That's the advantage in microcontroller. Then when we are using microcontroller, it's very small devices, not like a computer. අපි computer use කරන තැනට microcontroller එකකින් replace කරන්න පුළුවන්. That's the thing. Then when you are using microcontroller, first we have to write down program. අපිට එහෙනම් පළවෙනියට program එකක් ලියන්න වෙනවා. And same as the we have to prepare a small circuit. අපිට small circuit එකක් prepare කරන්න වෙනවා මේකට. And after that we have to upload that code and we can work it. That's the thing. Then when you are preparing that kind of microcontroller, when you are using that kind of microcontroller, first we have to program it. අපි කොහොමද නම් program කරන්නේ? For the programming we need computer. අපිට computer එකක් පාවිච්චි කරන්න වෙනවා මේක program කරන්න. And we need to use some board. අපිට microcontroller එක විතරක් අරගෙන computer එකට connect කරන්න බෑ. It's like that. This is the microcontroller, but we can't use directly microcontroller. We can't connect directly. Then we have to use development board. This is one of the development board. අපි කියන development board එකක් අපිට use කරන්න වෙනවා කියලා. Then this is one of the development board. That's the other development board. Then within that development board, මේ development board එකත් එක්ක අපිට facilities ගොඩක් ලැබෙනවා. Then there is some USB connectivity. Otherwise we can't connect that microcontroller to the computer, no. But in development board there is USB connectivity. අපිට මේ USB එකෙන් computer එකට connect කරන්න පුළුවන්. And same as the there are some input and output port. අපිට directly connect කරන්න පුළුවන් sensors සහ actuators and some other devices to the microcontroller. Otherwise we can't connect it, no. When you are taking like this microcontroller, we can't connect. Then we can use microcontroller board, development board. So මේකේ ගොඩක් options තියෙනවා. අපි කියනවා digital inputs and output, same as the analog input and output, power supply unit, and USB supporting, and same as the there are some other communication also. අපිට වෙන media හරහා communicate කරන්නත් මේක පාවිච්චි කරන්න පුළුවන්. Like a Bluetooth, if you need Bluetooth, if you need IR, then that kind of devices also you can connect there. ඒ වගේ devices connect කරන්නත් පුළුවන්. That's advantage. මම එතකොට ඔයාලට කියලා දුන්නා සහ ඔයාලට කිව්වා කලින්ම අපි use කරන microcontroller board එක ගැන. We are using Arduino microcontroller board. ඒක ගැන මම පොඩ්ඩක් කියලා ඊට පස්සේ ඊටු ටික කියලා දෙන්නම්. මොකද්ද මේ Arduino කියලා කියන්නේ? Why we are using Arduino? Then Arduino is the open source software plus hardware. අපි කියන Arduino කියලා කියන්නේ it's a open source. Not the hardware, not the software. It's a combination of hardware and software. අපි කියන hardware plus software. මේක ඇතුලේ include වෙනවා. අපි Arduino කියන එකට include වෙනවා. Arduino software සහ Arduino hardware කියන දෙකම. Then this is the Arduino hardware. අපි කියන hardware board එක. That's a one kind of board. You can see in software also. So we are telling that as a Arduino IDE. Arduino IDE කියන environment එක අපි use කරනවා for the programming. අපි මේ environment එක පාවිච්චි කරලා program කරනවා. And after that we can upload that code to the board. අපි මේ ලියපු code එක අපි code එකක් ලියලා ඒක Arduino board එකට upload කරන්න පුළුවන්. That's a simple thing. And not only Arduino. අපිට මේ Arduino විතරක් නෙවෙයි use කරන්න පුළුවන්. There are some many different kind of microcontrollers. කලින් අපි ඉගෙන ගත්තනේ. Arduino is a one thing. Arduino is Atmel. අපි එක group එකක් ගැන කතා කළා Atmel microcontroller. Then inside the Arduino board we are using Atmel microcontroller. Then same as there are some PIC microcontroller. අපි කියන PIC microcontroller series එකක් කියලා. එහෙම නැත්නම් PIC microcontroller group එකක්. And same as the Intel microcontroller also there. And epson microcontroller also there. Like that many different microcontrollers there. We can use anyone. But others are not open source. අනිත් ඒවා අපි කියනවා open source microcontrollers නෙවෙයි. එහෙනම් අපි ඒවට කියනවා closed source or commercial product. Then what's the main difference in between that? මේ දෙකේ තියෙන ප්‍රධාන වෙනස්කම් මොනවද? අපි Atmel එහෙම නැත්නම් Arduino ගත්තොත් it's open source. Then freely we can download that software. And you can buy that Arduino board also. අපිට මේ hardware kit එක සල්ලි දීලා ගන්න වෙනවා, but freely you can download software. But if you are using PIC microcontroller or epson microcontroller, then you have to buy their microcontroller and same as you have to buy their software also. Software environment එකට වෙනම සල්ලි ගෙවන්න ඕනේ. That's the difference. And these are some examples for the PIC microcontroller. If you are using PIC microcontroller, then you can use this kind of programs. මෙන්න මේ වගේ programs වලට පාවිච්චි කරන්න පුළුවන්. Like a microchip, MBLab, IDE. That's one software. And 𝗕𝗁𝗁𝗕𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁 programmer, pick debugger. මෙන්න මේ වගේ softwares collection එකක් තියෙනවා. You can use it. And 𝗕𝗡 also, you can use many different kind of software applications. Not only Arduino. Arduino විතරක් නෙවෙයි අපිට පාවිච්චි කරන්න පුළුවන් තවත් වර්ග තියෙනවා. 𝗕𝗡 Studio, then AVR GCC, AVR Studio, like that many applications there. But මේ ඕනම එකක් පාවිච්චි කරන්න පුළුවන්. But this one is not free. Then free software is Arduino. You can use Arduino free software. Then via that software you can program, you can write down the program, and after that you can work it in physical. Then this is the full structure. අපි මේ විදියට connect කළාට පස්සේදී මේ විදියට microcontroller එකක් use කළාට පස්සේදී මෙන්න මේ තියෙන structure එකට අනුව තමයි අපි board එක decide කරන්නේ. It's like that. First we can give the input. අපි කලින් ඉගෙන ගත්තා මොනවද input devices එහෙම නැත්නම් මොනවද අපි input කරන්නේ කියලා. Then we can give some of the physical changeable thing. It will changing their temperature, pressure, some of the weather condition, some of the gas leakage. Like this thing we have to detect. Then we can use many different kind of sensors. And same as we can give some data manually via the keyboard, via the touch screen. We can give some manual command or data. And after that, inside the microcontroller, we have to write down some program. Then according to that program, it will process. අපි කියනවා මෙතන microcontroller එක ඇතුලේ program එකක් ලියලා තියෙනවා. Then according to that program, it will work. And after that, we can take the output. අපිට එන output ගන්න පුළුවන්. Then what are the devices we can use for output? අපිට පුළුවන් speakers use කරන්න. Then we can use some of the meter, like a voltage meter, a pressure meter, and then a gas meter, like that many different meters we can use. Same as we can use some displays, like a mobile display, then monitor display, like that many different displays there. If you need to display some kind of output, then you can use display. And you can use some motors. Like if you need to control some mechanism, you can use motors. Then there are some different motors like DC motors, AC motors, gear motors, like that many different motors there. And same as we are using most of the time we are using LEDs and 7-segment display. Then if you need to indicate some condition, you can use LED. And you can use 7-segment for displaying some numbers. As a simple example, අපි හිතමු temperature එක display කරන්න ඕන. Or we need to display some numbers. 1, 2, 3 like that. Then you can use that 7 segments. Then most of the color light, they are using down counting system now. Then that counting value will display via the 7 segment. Like that. We can use these kind of input devices and output devices with the microcontroller. Then we have to take the input from input devices. Then after that, we have to process it and we can take the output from output devices. This is the structure of the IoT system and that's the structure of the IT systems in the computer also. First, we have to give some input. After that, we have to process it and we can take the output. අපිට මුලින්ම input එකක් දෙන්න ඕන. Then next we have to process it. Process වෙනවා microcontroller එකේ. And next අපිට output එක ගන්න පුළුවන්. That's the thing. Then if you are maintain IoT system, that condition you can transfer over the internet. ඔයාට මේ තියෙන input signal එක එහෙම නැත්නම් processing එක එහෙම නැත්නම් output එක over the internet transfer කරන්න පුළුවන්. That's the main difference in between microcontroller circuit and IoT circuit. අපි මේ දෙකට කියනවා embedded circuits and other one is the IoT circuits. It's like that. That's the theory part we have to discuss. And next we are doing some of the practical part. Yeah, you can take the 10-minute breaks and you can collect some of the component like this breadboard. You can collect the breadboard. Yeah, you can collect some of the breadboard. Same as you need some of the LEDs, 5 LEDs. You can take same as the you need that Arduino boards also with the cable. Arduino board එක කරගන්න cable එකත් එක්ක USB cable එක and you need some of the resistors also. අපි අගේ දාලා තිබ්බ value එක like that resistors. You can take the resistor. Value එක දාලා තිබ්බා 450 70 ohms. If you have 5, then it's okay. Then we can control 5 LEDs. And jumper wires also need. And most of the time we are using male to male jumper wires like that. Then directly we can connect that jumper wire to the breadboard. Like that we can plug it. And we have to use some of the switches also. Very small push button. Switch push button. It's a very small push button. We are telling that as a micro push button. Then we can use that for physical connectivity of that. Like that we can connect it. Okay, we can take the 10-minute break. විනාඩි 10ක break එකක් අරගෙන ඔයාලා එන්න. මේ බඩු ටික collect කරගෙන අපි ඊට පස්සේ practically මේ ටික connect කරන විදිහ මම කියලා දෙන්නම්.
Now.
Yeah, thank you so much. So now we are about to commence the session now. So we are so delighted to see like a lot of enthusiastic students are joined since 9:30. And before moving to the second session, actually we would like to call upon the head of academic of LNBTI, the Japanese IT University, Dr. 𝗕ጽ𝗥𝗗𝗂𝗓𝗓. Over to you, Doctor.
So I would like to thank all the participants, especially all the schools who have joined today. I think not only the local Sri Lankan students, so even the international community has been joining this session. So we are really happy to see all in this forum. So I think like we have done these kind of workshops, seminars time to time. So even physically in schools. So we know that like special requirement of this domain. So especially this IoT and other relevant technologies were introduced recently to Sri Lankan this curriculum. So therefore the teachers are like struggling, or sometimes they are having challenges in teaching those novel technologies. So therefore I think so we are really happy to share that knowledge we are having with all the participants who have joined today. And even in future, we would really love to come to you, your place, or even like having this nature of seminars to develop the knowledge of our children. So I think like especially the resource person like who's contributing to this session today, Mr. Chandana Deshapriya is like very well known in this domain and expertise, and I have done a lot of researches, have written various kind of books also in this domain, and doing a lot of innovations. So therefore we are really thankful for him also to do this kind of workshop for all the students who have joined here. I think අද දවසේ සම්බන්ධ වෙච්ච දුවල පුතාලා ඒ වගේම ආචාර්ය මණ්ඩලයේ විද්‍යාලවල හැමෝටම අපි ස්තුතිවන්ත වෙනවා මේ සෙෂන් එකට සම්බන්ධ වීම ගැන. මීට තිස්සෙල්ලා අපි පහුගිය වසරවල් වල ඔන්ලයින් මෝඩ් එකකින් විවිධ සෙෂන්ස් මේ වගේ කරා. මට ආරංචි වුණා අද උදෑසන ඉඳන්ම දරුවෝ ඒ වගේම ගුරුවරු බොහෝ පිරිසක් ලංකාවේ විතර නෙවෙයි ජාත්‍යන්තර මට්ටමේ පවා සම්බන්ධ වෙලා ඉන්නවා කියලා. ඉතින් අපිට ලොකු සතුටක් LNBTI ආයතනයෙන් මේ වගේ දෙයකට අපිට දායකත්වය ලබා දෙන්නට පුළුවන් වීම පිළිබඳව අපි විශේෂයෙන්ම දන්නවා. අපි මේ මම හිතන්නේ අපි සිලබස් එකට අලුතෙන්ම හඳුන්වලා දුන්න ඒරියා එකක් තමයි IoT කියන්නේ. ඉතින් බොහෝ විට අපි අර සමහරලාට අපේ ගුරුවරු නැත්නම් පාසල් වල තාම ඒක ව්‍යාප්ත වෙලා නැති නිසා ඒ දැනුම නිසා මම හිතනවා මේ වගේ දෙයකින් අපිට පුළුවන්කම ලැබුණා අපේ දරුවන්ට සහ අපේ ගුරුවරුන්ට ඒ අපේ දැනුම ෂෙයා කරලා ඒගොල්ලන්ට අලුත් දෙයක් එහෙම නැත්නම් අත්‍යවශ්‍ය දෙයක් මේ මොකද ලබා දෙන්නට ලැබීම පිළිබඳව අපි සතුටු වෙනවා. ඉතින් ඉදිරියේදීත් මේ වගේම ඔබේ පාසල දුරට ඇවිල්ලා ඒ වගේම මේ වගේ ඔන්ලයින් මෝඩ් එකකින් මේ වගේ දේවල් කරමින් දායකත්වය ලබා දෙන්න අපි සතුටින් සදී පැහැදිලි සිටිනවා. ඉතින් මේ සෙෂන් එකට දායකත්වය දුන්න චන්දන දේශප්‍රිය මහතාට අපේ LNBTI ආයතනයේ ප්‍රවීණ ආචාර්යවරයෙක්. ඉතින් එතුමාට අපි ස්තුතිවන්ත වෙනවා අද දවසේ මේ වගේ බොහොම ඵලදායක සෙෂන් එකක් බොහොම ඉන්ටරෙස්ටිං විදිහට හැමෝටම ඉදිරිපත් කිරීම පිළිබඳව මම හිතන්නේ මේ සෙෂන් එකෙන් අපිට නවතින්න නැතුව අපිට පුළුවන් අපේ Facebook පිටුවේට ඔබට ආවොතින් මම හිතන්නේ එතන අපිට පුළුවන් ෆෝරම් එකක් ආරම්භ කරන්න ඔබේ තියෙන ප්‍රශ්න යොමු කරන්න. ඒතර අපිට පුළුවන් මේ දේශප්‍රිය මහතාගෙන් ඔබේ තියෙන ප්‍රශ්න වලට විසඳුම් ලබා දීලා කියන්නේ අද මේ සෙෂන් එක මෙතනින් ඉවර වෙන්නේ නැතුව ඉදිරියටත් ඔබට කන්ටිනියුස්ලි සපෝට් කරන්න පුළුවන් කියලා මම හිතනවා. මම හිතනවා අපේ මේ සංවිධායක මණ්ඩලය වෙනුවෙන් ඔබට සහයෝගය ලබා දෙයි කියලා බලාපොරොත්තු වෙන බොහොමත්ම ස්තුතියි.
ඔව් කෙටි හැඳින්වීමක් ડોක්ටර්. අතරම අපේ Facebook page එකේ මේ සම්බන්ධයෙන් අපි post එකක් දාලා දෙනවා. අපි ඒක pin කරලා තියෙන උඩට. එතන ගියොත් ඒ post එකට අදාළ comment section එකේ තමන්ට අවශ්‍ය ඕනෑම ප්‍රශ්නයක් ගැටලුවක් සහ ඉදිරියට මෙවැනි sessions තමන්ගේ schools වල කරන්න අවශ්‍ය නම් ඒක අපිට දැනුම් දීමක් කරන්න පුළුවන් comment section.
මම හිතන්නේ බොහොම වැදගත් පණිවිඩයක්. ඉතින් අපි හිතනවා මේ අවස්ථාවෙන් ඔබ හැමෝම ප්‍රයෝජනයක් ලබා ගන්න කියලා බොහොම ස්තුතියි. මම ආරාධනා කරන නැවතත් දේශප්‍රිය මහත්මයාට මේ session එක කන්ටිනියු කරගෙන යන්න.
Okay, I think all of you are joining again to this session. And all of you are collected that materials ළඟ තියෙන පුතාලා දුවලා ඇති. ඒ වගේම materials ළඟ නැති අයත් ඇති. It's okay. ප්‍රශ්නයක් නැහැ. අපි materials තියෙන අයට hardware connect කරන විදිය මම කියලා දෙන්නම්. ඒ වගේම materials ළඟ නැති දුවල පුතාලට අපිට online simulation tool එකක් use කරලා මේක draw up කරන්න පුළුවන්. ඒ ක්‍රම දෙකම මම ඔයාලට explain කරන්නම්. I'll explain both online simulation and physical connectivity of that both. And I think all of you can see my screen. Everyone, can you see? Yeah, okay. Then in Arduino means it's one of the software plus one of the hardware. අපි මේ Arduino කියලා කියන්නේ software එකකුත් නෙවෙයි hardware එකකුත් නෙවෙයි අපි මේ දෙකේම combination එකකට තමයි Arduino කියලා කියන්නේ. It's a free and open source software. Free means we no need to pay for that software. Freely we can download that software and same as the we can use it. අපිට මේක freely download කරලා use කරන්න පුළුවන් software එකක් තමයි මේ open source කියලා කියන්නේ. Around the world we can use it. And we can do many projects via that software. අපිට මේ software එක පාවිච්චි කරලා free projects කරන්න පුළුවන්. Then first we have to identify what are the different boards. When we are using only one boards now. Then many different boards there. අපි කියනවා like a Arduino Uno board, then Nano board, Div board, Micro, Mini, like that many different boards there. මේ වගේ එක එකට වෙනස් boards වර්ග ගොඩක් තියෙනවා. අපිට මේ boards පාවිච්චි කරන්න පුළුවන් විවිධ purpose වලට. Like in sometime we need to make a very small circuit, very small embedded system, very small IoT system. Within 2 centimeter box. අපි හිතමු centimeter දෙකේ box එක we have to prepare that. Then we can use that micro or mini boards for that. And in some time we need to collect very large size of robot system and IoT system also. Then like that project we can use mega board, div board, like that board we can use. So අපිට එක එක purpose වලට මේ තියෙන විවිධ boards use කරන්න පුළුවන්. And when you are using that different kind of board, it's like that Arduino Uno, Arduino Leonardo, then a Micro, Mini, Nano, Div, like that many different boards there. Then that different kind of board, විවිධ boards වල memory ප්‍රමාණය විවිධාකාරයි. Like that there is some RAM, ROM, then internal flash memory and working speed that are very different. So අපි හදන්න යන product එකට අනුව තමයි we need to decide that, we need to select that. And their working speed also different and physical size also different. But programming language is common. එකම programming language එක තමයි අපි මේ හැම board එකකටම use කරන්නේ. That's like a C++. අපි කියන C++ කියන language එක. I think most of these students know that C++ language. It's a very basic and very simple language. Then we are using that language for build up code through the Arduino IDE software, integrated development environment software we can use for that. Next we have to identify their structure. අපි දැනට අපි use කරන Arduino Uno කියන board එක. That's a first board of Arduino. That's a meaning of Uno. Then we can use that Uno boards. Then when we are taking that Arduino Uno boards, it's a two different type of Uno boards there. We are telling that's two different type of Uno boards. That's one thing, that's the other thing. Like that two different boards there. This one and that one. In the presentation also you can see. Then within this Uno board, there are a larger size microchip. අපි කියනවා Arduino Uno chip, that's very large size. Same as this one. Then other one, very small IC is there. This one very small. In here, you can see this one. Like this. Then, but this one and that one, both are same. Methane ICs, they come samana. We are telling that as this is a normal chip. That's a surface mount chip. Surface good mount karana puluwan chip එක. Like in your mobile phone, in your laptop, desktop computers, they are using surface mount IC, this one. Then what's the difference in between that one and this one? Only the difference is power usage. This one is using some very large power. And we can connect some of the motors and some actuators to there. But this one is not like that. They are using very small amount of power. Because of it's a very small IC, then we need to provide a small current for that. Working voltage is same. It's a digital board working with 5 volt. We can connect that both board to the USB port. But the USB port connect kalla, we can program it. Then in here, in this board, there are 14 pin. Pin 14 digital side. We are telling that as a digital side. Then starting with 0, 1, 2, 3, like that up to 30. Then this is the digital side. They are including 14 pin. And same as their memory. Internal 32K flash memory appear. That's a very small memory comparing with our hard disk and our other memories. But we can use this memory for only the programming. අපිට program එක upload කරන්න තමයි මේ memory එක use කරන්නේ. And same as the we can use 2 kilobyte RAM. Very small RAM is there. Comparing with our laptop and desktop RAM, it's a very small. But for this microcontroller, it's enough. මේ microcontroller එක ගත්තොත් අපි microcontroller එක ඇතුලේ pins 14ක් තියෙනවා digital pins. Same as the memory තියෙනවා 32 kilobytes and RAM එකක් තියෙනවා 2 kilobytes. We can use that for programming. Then this is the normal structure. First, this is the digital input and output side. Another side, analog input side and digital output. If you need a digital output, then you can take the from this side. මේ පැත්තෙන් අපිට ගන්නත් පුළුවන්. Same as we can take the from here also. And the special thing is this pin we can use for analog input. අපිට analog input එකක් දෙන්න මේ ටික පාවිච්චි කරන්න පුළුවන්. And these are the power pins. We can use this pin for taking power out. අපිට එළියට power ගන්න පුළුවන්. Same as we can give the power to the microcontroller board also. And same as there are 2 power sockets, USB programming socket, and the other one is a 12 normal DC power connecting pin, like that. First, you can write down some program, and after that you can use some of the mobile charger, or you can some of the other power adapter, and you can connect that here, and you can work this board without computer or any other thing. After write down your programming, you can do it. ඉතා සරලව අපිට මේකේ program එකක් run කරන්න පුළුවන්. It's like that. Then same as the I'm telling that another board is there. Then a micro, nano, mini, like that very small board also there. Then you can connect that to the USB, same as previous board, and you can program. Then same as this board, the difference is board size is small. මේ board එකේ තියෙන එකම වෙනස board එකේ size එක is very small. Then micro, nano and mini, like that 3 different boards there, that all 3 are same to the Uno board. එකම micro chip එක තමයි තියෙන්නේ, that surface mount chip එක, this one, but size is different. That's the main difference. Other features are same. Pin numbers, their other all settings are same. එකම එක වෙනසයි තියෙන්නේ board එකේ size එක වෙනස් විදිහට හදලා තියෙනවා, like that. And there are some larger size board. We are telling that as a mega board. In the mega board, we are using very large size IC. Mega board එක compare කළොත් අපි මේ තියෙන board එකක් එක්ක it's very large size. Then it will taking more pins. Then digital pins like a 54 digital pins there. Digital pins 54ක් තියෙනවා. and it will include more memory, like a 256 kilobyte and 8K RAM also there. It's a very large size RAM and flash memory. Then you can write down one very large size program there. අපිට විශාල program එකක් ලියලා මේකට upload කරන්න පුළුවන්. Like a main thing like a robot controlling. අපි තුම robot කෙනෙක් අපිට control කරන්න ඕනේ කියලා. Then we can write down very large size program and we can upload there and we can work. And we can connect multi devices because of there are a set of pins there. No, we can connect some of the displays, some of the sensors, actuators, like that. Many things you can connect there. And next, first we need to identify that Arduino IDE software. Then you can download that Arduino IDE software from internet freely. When you are going to that Arduino website, just you can type www.arduino.cc and you can go to that website and you can download that Arduino software. There are two different softwares there. There are many different type of softwares there. Then according to the operating system, you have to download that. එක version එකක් නෙවෙයි තියෙන්නේ, versions වර්ග ගොඩක් තියෙනවා. ඔයාගේ computer එකට match වෙන විදිහට ඔයාලට මේ software එක download කරගන්න පුළුවන්. මම හිතනවා දැනටමත් අපේ දරුවෝ download කරගෙන ඇති කියලා software එක. Then otherwise you can use that. මේක download කරගන්න පුළුවන්. එහෙම නැත්නම් ඔයාලට online environment එක use කරන්නත් පුළුවන්. Then you need to download that. But you need internet connectivity for online environment. අපිට online tool එක use කරන්නත් පුළුවන්, offline use කරන්නත් පුළුවන්. Offline use කරනවා නම් ඔයාලට software එක download කරගන්න වෙනවා. And next, ඊට පස්සේ අපි මොකද කරන්නේ? දැන් අපි software එක download කරගත්තා කියලා හිතමු. We have already downloaded that. Next, we need to connect that Arduino board to the USB like that. In your computer, laptop or desktop, you can connect like that. It will given like this cable, USB cable, type A and type B. Then you can connect that type B side to the Arduino board like that. You can plug it. And for the other side, you can connect it to the USB port in your computer. Like that, you can plug it. I have plugging that to the USB port like that in here. Then when you are plugging that, you can see that LED, one of the LED will switch on here. Then we can see it like a power LED. It will mention there power on LED. And you can see some other LED in here, L LED also there. Time to time it will blink. මේක නිමිනිමි පත්තු වෙන LED එකක් මෙතන තියෙන පුළුවන්. සමහර විට මේ LED එක දිගටම පත්තු වෙලා තියෙන පුළුවන්. That depend on your program. දැන් already program එකක් දාලා තියෙනවා නම් ඒ program එක අනුව මේක වෙනස් වෙන්න පුළුවන්. But when you are taking empty board from shop, it will including some testing code. Then while that testing code, it will including some LED blinking. අපි කියන LED එක blink වෙන testing code එකක් තමයි මේක default program එක විදිහට upload කරලා තියෙන්නේ. That manufacturer. අපි කඩෙන් ගණිතී ඒ වගේ code එකක් මේකේ include කරලා තියෙනවා. But we can change it. අපිට මේ code එක change කරන්න පුළුවන්. We can upload any code there. අපිට කැමති program එකක් ලියලා we can upload there. Then when you are uploading new code to the Arduino board, the old one will erase automatically. කලින් ඔය upload කරලා තිබ්බ code එක automatically erase වෙලා යනවා. අලුත් code එක තමයි ඊට පස්සේ වැඩ කරන්නේ like that. I think that part is clear. Then you can connect like that way. Then after that we have to set up their software. දැන් මේ hardware එක හරි, hardware part එක okay, connect කළා. ඊට පස්සේ අපි බලමු මේක කොහොමද අපි software එකට connect කරගන්නේ. Then we have to connect to the software. Next, first you can open the Arduino software. Or download කරපු Arduino software එක you can open. When you are opening it, it's getting like that. Then menu bar, button bar, like that, many different interfaces there. Then the first one, menu bar. Menu bar is top one. When you're opening that Arduino software, it will taking like that. In the top one, menu bar. Then there are some icons like a file, edit, sketch, tools, help, like that set of icons there in menu bar. And after that, button bar. Then there's some set of button. We can use that button for uploading, compiling, opening new software, or save it, like that many purpose. අපිට මේ program එක compile කරන්න එහෙම නැත්නම් compile එක අපි ලියපු program එක check කරන්න මේක පාවිච්චි කරන්න පුළුවන්. Then we have to upload that to the board. Then we can use second one, like that. For many things we can use it. අපිට මේක පාවිච්චි කරන්න පුළුවන්. අපිට new එකක් open කරන්න ඕන වෙනවා. එහෙම නැත්නම් කලින් අපි save කරපු program එකක් open කරන්න පුළුවන්. Like that we can use it. The next, coding area, the middle part. We are using this middle part for coding. Then we have to write down some programming. No, it's a very small program we can write down. And after that, we can check the errors. We can click on that correct mark. Just you can click it. Then it will show their status. If there is any error or if there is any failures, then you can see it in here. මෙතන පෙන්නනවාට මොනවාද errors තියෙන්නේ කියලා. Then notification area. Then within that notification area, it will show the notifications. වගේ program එක කොච්චර size එක කීයද, same as the program එක upload වුණාද, like that condition you can see in here. If there is any error, then what's the error? මොන වගේ error එකක්ද ආවේ? Like this thing you can see in here. That's the interface for Arduino. We are taking that as Arduino IDE. The next, first you have to connect Arduino board like that to the USB. Arduino board එක අපි USB එකට connect කරනවා. And ඊට පස්සේ අපි software එක open කරගන්න මේ විදියට. Then next you have to connect that board. අපිට board එක මොකක්ද කියලා select කරන්න වෙනවා. Yeah, if you are taking new software, like it's a new version of the software, it will taking some different. මේ තියෙන interface එකට වඩා පොඩ්ඩක් වෙනස් වෙන්න පුළුවන්. අලුත් environment එකේ software එක ඔයාලා download කරලා තියෙනවා. That's also same. It's okay. මේට වඩා වෙනස් වෙන්න පුළුවන්. And same as there are some different versions. මේ තියෙන software එකේ මේට වඩා වෙනස් versions ඔයාලට තියෙන්න පුළුවන්. ප්‍රශ්නයක් නැහැ. ඒ ඕනම version එක common icons ටික තියෙනවා. The file icon, edit icon, sketch, tools, then same as the compiling, uploading. That are the common icon. ඒ icons ටික මේ ඕනම software එකක තියෙනවා. Yeah. ඊට පස්සේ අපි බලමු කොහොමද මේ Arduino software එකට අපේ board එක සම්බන්ධ කරගන්න කියලා. දැන් අපි board එක මේ වගේ connect කරලා තියෙනවා. මේ connect කරපු board එක අපි කොහොමද සම්බන්ධ කරගන්නේ මේ තියෙන software එකට. Then first you can go to the tools. ඔයාලගත්ත Arduino එකේ tools වලට යන්න. You can go to the tools and you have to select what's the board. මොන board එකක්ද ඔයා අරගෙන තියෙන්නේ. You can go to the tools and click on the board. Then you can see many set of boards there. Boards වලට ගොඩක් පෙන්නනවා. Then you have to select Arduino Uno. Your board is Arduino Uno, then you have to select that. Otherwise it will not working. Then you can go to the tools, board, select the board. If you are connecting mega board, then you have to select mega board, like that. What's the board you are connected to the USB port, then you have to select it. Then again, then the same as the, you can go to the tools again. Tools you can go to the port. Board කියන එකට යට there is some port. Second icon you can see port. Then you have to select that port also. Then what's the port you are connected? මොන port එකටද ඔයා මේක connect කරේ? ඉතින් Arduino software එකේ ports වර්ග ගොඩක් තියෙනවා. අපි කියන computer එකේ ports ගොඩක් තියෙනවා. මේක මොන port එකටද computer එක connect උනේ? We are taking that as a COM port. Then it will so COM port 1, COM port 2, COM port 3, COM port 10, 11, like that many number of COM port. Then which the COM port, it will automatically detect that. That's okay. only that. Then it will detect automatically. Okay, then I will show that. I will open the Arduino software and I will show that. I think all of you can see my screen. I have shared full screen. Then when you're opening Arduino software, it will take me like that. This is one of the version of Arduino. It's Arduino like 8.1.8.19. That's the version. Version that interface will differ. Interface but this is the one of the interface. Then first I'm connecting that Arduino board to the computer, and first we can go to the tools. After the tools option and we can select first the board. Then Arduino Uno. Like that you can select. Tools, board, AVR board, it's Arduino Uno. It will select it. Like that, a small dot will display in here. Then after that you can select the port. Ekam option tools port then you can connect port like a Arduino Uno. It's connected to the COM port 3 like that. Then board will detect it. Board detect computer. Now it's okay. The price is I think 3,500 or something. Yeah, around 4,000. Yeah. Uno board. This Uno board around 4,000 or 3,500. Yeah, in Sri Lankan rupees. There are some different kind of board, but that's the original board. There are some Chinese board. You can take the 2,000 or 2,500, but there are some trouble in that board. You can say original board use කරන්න. මොකද සමහර ඒවා computer එකට connect කළාම වැඩ කරන්නේ නැතුව යනවා. You can use this board, this type board or that type board. Surface mount board or anyone. That's okay. ඕන board එක පාවිච්චි කරන්න පුළුවන්, but you have to use original board. Then next I will explain that coding interfaces. How we will code it. කොහොමද අපි මේක code කරන්නේ? Next, when you are opening that Arduino IDE, you can see there are two parts. Mega parts දෙකක් වලට පෙන්නාවි. First part is void setup. Second part is void loop. There are two parts. We are telling that as a two functions. Then when you are opening some program like that, we are telling that as a sketch. අපි කියන මේකට programming sketch එකක් කියලා. Like one of the program. Then we can write down some setup part and we can write down some loop part. මේක කොටස් දෙකක් තියෙනවා, setup එක සහ loop එක. Setup mean when you are taking some of the board like that, you have to set up it first. No, like what's the pin you need to get output, what's the pin you need to connect as an input, you have to set up. Like when you are taking some of the brand new product, brand new item like your mobile phone or any brand new equipment, first you have to set up it. Then same as the when you are taking that board also you have to set up. එහෙනම් අපි board එක set up කරන්න තමයි මේ set up කියන option එක පාවිච්චි කරන්නේ. Then we can set up like that. අපිට පුළුවන් board එක set up කරන්න මෙන්න මේ විදිහට. කොහොමද? Then inside the setup you can write down their pin mode. Pin එකක mode එක අපිට වෙනස් කරන්න පුළුවන්. Pin mode mean it's the input or it's output. Then this is one of the example, like pin number 3, we are setting as an output. අපි pin number 3 එක output කරනවා. Then we can take the signal from pin number 3. අපිට pin number 3 එකෙන් එළියට signal ගන්න පුළුවන් as output. If you are set up this as an input, then you can't take the output. Then you have to give some input to the board. Like that. Then a pin, after that pin mode. Then this one is case sensitive. Because of that, when you are writing keyword, you have to write with the capital and simple. Then pin mode, pin is a simple, then mode, first letter is capital, like that. And these are the keywords. Output, you have to write down with the capital letters. Then it's working like that. Output taken to the outside. So pin number 3 එක output උනා. එහෙනම් අපිට pin number 3 වලින් එළියට signals ගන්න පුළුවන්. It's like that. Then next, after that loop 1. Loop is the program. Then first we are set up the board. Next we have to write down program. අපිට board එක set up කරන්න නෙවෙයිනේ ඕනේ. We have to write down some program, light up LED. මේ LED එක light up වෙන්න තමයි අපිට program එකක් කියනවා. Then we can write down some program inside the loop. We are write down program inside the loop. අපිට මේ program එක ලියන්න වෙන්නේ loop කියන කොටස ඇතුලේ තමයි. Then first, normally we are using some of the digital. This side is digital 0 to 13. These are the all numbers in digital side. Then you can use digital command. After that, you need to take some output. Then 5 volt එකක් වට එළියට ගන්න ඕනේ. Then you can write down keyword like a write. Digital write. Then you can write down digital write pin number 3 high, like that. High means it's a logic level 1. There are two logics now, logic 1 and logic 0. අපි කියන logic 1 සහ logic 0 කියලා. In digital world, we can identify that as a 5 volt and 0 volt. අපි කියන 5 volt සහ 0 volt කියලා. අපිට 5 volt ගන්න පුළුවන්, 0 volt ගන්න පුළුවන්. So 5 volt වලදී අපිට LED එක on කරන්න පුළුවන්. 0 volt දුන්නොත් අපිට LED එක off වෙනවා, like that. We can on the LED and we can off the LED. අපිට LED එක on කරන්න පුළුවන් සහ off කරන්න පුළුවන්. ඒක on කරන්න නම් අපි high කියන logic එක දෙන්න ඕනේ. We need to give logic high. It's like a 5 volt. Then the next one is for switch off, we can give logic low. Then it switch off like that. And we can connect one of the LED. අපිට LED එක connect කරන්න පුළුවන් to the pin number 3 and other side is to the ground. අපි කියන GND. Like when you are connecting LED, there are some two pins. Pin දෙකක් තියෙනවා, positive සහ negative. Then how we can identify that positive and negative? කොහොමද අපි මේකේ positive සහ negative හොයාගන්නේ? The method is long. There are some two pins you can identify. When you are taking LED, it's two pins. Like pin number 1 is long one, other one is short one. Like that, two pins are there. Then long one is the positive one, short one is the negative one. Then short one and long one. Like that, you can connect it. ඔය pins දෙකම වලට connect කරගන්න වෙනවා. එතකොට මේ long pin එක තමයි අපි positive කියලා කියන්නේ. Then we have to connect that for the Arduino pin. And other side is the negative one. එක negative පැත්තට connect කරන්න පුළුවන්. But there's some problem. Arduino board එක වැඩ කරන්නේ digital එක. It's working with digital. Digital means 5 volt. But LED, we can't connect LED to the 5 volt. And if we are connected LED to the 5 volt, then what will happen? It will blast. No, it will burn. අනිවාර්යෙන් පිච්චිලා යනවා. Because of LED is not working with the 5 volt. It's working with only 3 volt or 3.5 volt maximum. Then we can't provide 5 volt for that. 5 volt දෙන්න බෑ. එමුණත් මොකද වෙන්නේ? අනිවාර්යෙන් LED එක පිච්චිලා යනවා. Because of that, we have to connect one of the resistor there. Then we can use one of the resistor to reduce current going through the LED. LED කරා යන current එක අඩු කරන්න අපිට පාවිච්චි කරන්න පුළුවන් මේ දින resistor එක. Then which kind of resistor we can use? මොන වගේ resistor එකක්ද අපි පාවිච්චි කරන්නේ? Then many more values there, no? Then it will providing 5 volt there, and then voltage difference is 5 volt. Then the LED working with maximum 3 or 3.5. Voltage එක 3ක් තෝ 3.5ක් තමයි මේකට දෙන්න පුළුවන් අපි. ඒක නිසා මොකද කරන්නේ අපි? We can connect 470 ohms or 330 ohms. අපිට මේ දෙකෙන් එකක් පාවිච්චි කරන්න පුළුවන්. Or otherwise you can use some of the 1K or 1.2K, but if you are connecting that kind of resistor, it will getting very small light. අපිට බොහොම පොඩි ආලෝක ප්‍රමාණයක් තමයි ගන්න පුළුවන්. ඒක නිසා අපි පාවිච්චි කරන්නේ නැහැ ඒ තියෙන resistor එක. We can use only for the 470 or 330 ohms. Like that, we can connect it. Then when you are connecting that resistor in the market, you can buy this resistor in any electric shop. You can buy it and you can connect that resistor according to this structure. අපි මුලින්ම Arduino board එකේ pin number 3 වලින් පටන් ගන්න. Then resistor first and next LED positive negative. Another side is going to the negative side, like a battery negative. Like that we can connect it. And next we have to write down small program. No, without program we can't do it. No, and this is the one example. We can write down inside the void setup. We can write down pin mode, pin number 3 output. Then next in the digital, in the loop part, after loop එක ලියන්න පුළුවන් digital write pin number 3 high. Then LED will light up. After that we need to wait some time. Light එක on කරලා ඊට පස්සේ අපි light එක off කරන්න යන්නේ. But light එක on කරපු ගමන් අපි off කළොත් මොකද වෙන්නේ? Suddenly you are switch on it and suddenly you are switch off it. Then it will not working now. You can't see it now. Because of that you have to wait some time. Then we can write down some delay. Then a delay 1000. Delay 1000 means it's a 1 second. It will write down by the millisecond. Millitappar වලින් තමයි ලියලා තියෙන්නේ. Millitappar 1000 equal 1 second. Then we can write down like that way. Digital write pin number 3 high, then wait 1 second. Again digital write 3 low, then 1 second. Like that we can write down simple program. Okay, you can connect one of the LED and you can try it. But if we haven't that Arduino boards or LED, then we can use some of the online simulation tool. I will explain that also. Then you can go to this website. Website is 𝗕𝗏𝗏𝗃𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏. I put that into the chat box if you need. You can keep that link. You can go to that website. That's also open source online website. You can go there and first you have to register. Okay, I will show that website. It's taking like that. When you are going to that website, and after that you can register. There's a sign up. After sign up, it will getting like this environment for you. There are two parts, 3D design part and circuit part. In here, we are going to the circuit designing part. And you can take some new circuit within here. Or otherwise, you can take some of the previous one. Just I will open some of the previous one and I will show that. Circuit they are taking some time for loading. Yeah, it's like that. then one of the breadboard, and there are 2 LEDs and 2 resistors, and one of the Arduino Uno board. It will connected. Then that's one of the example. Then I will show how to connect like that board and other component according to this structure. අපි බලමු මේ විදිහ එකක් අපි කොහොමද online environment එකේ connect කරන්නේ. It's a very simple. මම මුලින් ඉඳලම ඔයාලට කියලා දෙන්නම්. First you can go to the website and you can register, and after that you can go to that circuit simulation environment, and if you are taking to that environment, it will getting empty environment like that. When you are going to the first time to this environment, it will taking like that empty paper. That's a worksheet. මේ වගේ සුදු පාට කොලයක් එවි when you are taking there. Okay, we will show physical one also. Then first we can take the breadboard. අපිට මුලින්ම breadboard එක ගන්න වෙනවා. Physically also you can take the breadboard. Physically board එක තියෙන අය breadboard එක අරගන්න. ඒ වගේම software එක use කරන අය software එකේ register වෙලා breadboard එක අරගන්න. Then when you are taking breadboard like that, it's taking like that. You can see. I think software is very easy to the physical view, comparing with physical view, no? Then it will taking like that. Then in the top side, you can see there are some minus line. උඩ පැත්තේ තියෙන නිල් පාට line එකක්. You can take the that blue color one or black color one in the top side. You can see like that. And same as the second one. Red color lines there. We are taking that for positive. Negative and positive. It's like that. This is the negative line. This is the positive line. Then the same as in the middle there are some other part. Then it will mention like A, B, C, D, E, F, G, H like that. It's starting from this corner and it will going up. And there is some number system, number 1, 2, 3, 4 like that. 1 to 30. If you are using a small breadboard, that's the middle one. Then it including some of the points 1 to 30. If you are taking larger one, then it will go in double 1 to 60 or 1 to 100 like that. According to the different sizes, you can take it. මීට වඩා වෙනස් boards වර්ග තියෙන්න පුළුවන්. එක එක boards වර්ග තියෙනවා. You can use anyone. Their structure is same. Then next we need one of the LED. අපි LED එක කරගමු. We can take the one LED and we can connect that LED. LED එක ගත්තා නම් අපි ඒක positive negative හොයා ගන්න ඕනේ. Positive side and negative side. This is the positive side, this is negative side. කොහොමද අපි හොයන්නේ? One pin is long, other one is short. Shorter pin is negative. Then you can connect that shorter pin into the negative side of your breadboard. මේ පහළ තියෙන black or blue line එකට connect කරන්න පුළුවන්. In one side. You can connect like that way. I think you can see it like that.
Short pin into negative side.
Yeah, short pin is into the negative side, long pin into the some other pin in the board.
LED, this one shorter and this one longer. So this one negative and this one plus. So you can pin like this.
Yeah. In the software, you can't connect like that. Then you can connect negative pin in there. Then a positive pin, you can connect into some other like that.
They know about how breadboard connected, no?
Yeah. I think all of you can connect
You
it.
can check that thing like this in this way. You can see.
Yeah. in the back side.
These are the parts how they connected in breadboard.
All the pins like a B, C, D, E are connected together like that. Like a line 1 pin connected together, then line 2 pin connected together like that. But line 1 and line 2 not connected. It's a separate. Connected. It's a 2 different lines. Then you can connect that LED to the negative side and other one to the positive side. Any positive line. I think all are connected. If you have any trouble, you can send the message. Put into the chat box. Next, we are taking the resistor. ඊළඟට අපි resistor එකක් ගමු. Then one of the resistor we can take. Then you can use 470 ohms. I will change that 470 ohms like that. Then the color range is like that. I think all of you know the color range, yellow. Then it's like that. According to this order, you can identify it, color range. Then if you
purple and yellow.
Yeah, brown, purple, and yellow. Then it will starting from yellow side. Then yellow, purple, brown, like that. Then this one is like if you have a 330, then I will show their color range. Then orange, and next one is the brown, like that.
I have to catch in that gold color line side, and then you can read the lines like yellow, purple, and brown in that figure. And
next you can connect that one of the resistor like that way.
Aside of the LED.
Yeah, one side of the LED you are connected in the middle. You have to connect your resistor to the same line. And what's the line? Like in here, it's connected to the line 8. Then you have to connect your resistor also to the line 8. To the same side. And other side you can connect in anywhere. In the top side.
For this side also can use it.
Yeah, that side also you can use. But if you are connected that according to this order, then it's very clear and it's very easy. You can use this side also, this side or that side, any side. But if you are connected according to this structure, then it's very clear. Then next we have to take the Arduino board. Like that, we can take the Arduino board. And we can connect it. When you are connecting that circuit on the Arduino board, first you have to remove from your USB port. අනිවාර්යෙන් ඔයාලා USB port එකෙන් remove කරලා circuit එක connect කරන්න. Otherwise what will happen? If it is short circuited, then it can damage your USB port. In some time, if it is short circuited, like you are connecting some wires, to the positive side and negative side, because of that, it can short circuit it. Okay, then you can take the 2 wires like that way. You can take the 2 wires, and one of the wire you can connect to this negative line. Any pin in the negative line. අපි අර resistor එක ගහපු LED එක connect කරපු negative line එකේ ඕනම pin එකකට connect කරගන්න. Like that.
Negative.
Yeah. And you can connect other end of the wire to the GND pin. Like that you can connect it.
Negative pin into ground.
Into the ground. I'm using blue color for that. blue color wire, and I will connect like that. Yeah, GND. In here, GND, you can see. There are 2 pins. You can connect any GND pin. This one or that one. And the other end, then there are some positive end. No? You can connect one wire here to the same line. May line එකටම අනිවාර්යෙන් connect කරන්න. Not for this one or that one. You have to connect that into the same line. And you can take that to the out, and you can connect that into the some digital pin. Then what's the digital pin you are using for programming? Then you have to connect for that. Like we already use pin number 3, then you can connect that to the pin number 3. I'm using some of the orange color wire. Like
from 1 to 13, there are 13 digital pins.
Yeah.
There are 13 digital pins.
You can use any one.
Here you can see analog pin. 5 analog pins.
6. It's starting with 0.
So
you can connect any of the digital pin because of we are using digital programming. You can use analog one also.
I connected that to digital pin 6.
Okay. Then you can use any digital pin there. Then after that, again we can go to the programming environment. Arduino Sketch. Then when you are opening Arduino Sketch, it's getting like that. Then void setup is there and void loop is there. But we are never writing anything. Then it will show some messages for you. Put your setup code here to run once. Like that message show for you. Then you can get, that's a comment. That's just one comment. You can write down any command here for setup. Setup කරන්න ඕන වෙන command එක මෙතන ලියන්න කියලා තමයි example එකක් දීලා තියෙන්නේ. Just you can remove that. Because of we no need that, no. You can remove that. And you can write down some program there. And what's the program we need? Program is this one. Pin mode, pin number 3 output. We need to set up pin number 3 as output. Then I will show that how to write the program. We can write down pin mode. Mode means it's a capital. Pin mode. Then a pin number 3, comma, output. Like that we can write it. Then pin mode means pin is the one thing, mode is another command. Like that 2 commands there, we can connect with together by this method. First letter of the second word, capital. දෙවෙනි word in එකේ පළවෙනි letter එක capital කරලා first එකත් එක්ක join කරන්න. It's like that. And after that we can end the line. අනිවාර්යෙන් අපි line එක end කරන්න ඕන. We can type semicolon there. Or line ending. If you need, I will copy and paste that into the chat box. Like that, we can write down some setup command. Just only that. Then pin number 3 setup as output. Yeah. Then if you are connected to the pin number 3 or pin number 4, pin number 5, any digital pin, then according to that, you have to change that number. What's the pin you are selected, then you have to change that. Then here it will connect at pin number 3. Because of that, I am set up that as a pin number 3. In physical one, I am connected that into the pin number 6. Then if you are using this circuit, then we have to change that as a pin number 3. 6 also. Like that. Then next we are going to the setup part. Api setup කරපු එක ඉවරයි. Next we are going to the loop. Then your main program you can write down in here. That's a message. You can remove it because of we don't need that message. And we are write down some program for light up LED. Then digital write pin number 3 high. Like that. Digital. Then write pin number 3, comma high. Like that we can write down program. very small program. Then if it is connected to one LED to the pin number 3, it will light up. And after that, we need to take some time, delay. Then we can write down what's the delay time. We can write down 1000. 1000 is equal to 1 second. Yeah, it's a 1000 millisecond. It's equal to the 1 second. Then again, we can switch off LED. That's a switch on condition. Okay, first we can try it. Without switch off, we can try that. I will put that in the chat box. If you need, you can copy and paste it. Just try it. Then how we compile that? First, we have to identify if there is any error. Then you can click on the first icon, like a verify. Then they're asking some message for save that. I will save that on the desktop. Then you can give some proper name here, LED1. Like that name you have to give without a space. මෙතන ඔයාලා type කරන නම space එකක් නැතුව type කළ යුතුයි. If you type any space, then it will getting some errors. You can give some single name like that, LED1, then save. Then they will check if there is any error. If there are error, then it will show in there. You can identify that. It will taking some time. Then after compiling, it will show like that message. That's the usage of the program. They are using 2% from their main memory. Like that. That's the size of main memory. They are using very small amount of memories. And program, there are no any errors in the program. Then done compiling, like that message will show. And after that, we need to upload that code to the board. Then අපි program එක ලියලා ඉවරයි. Program එක board එකට upload කරන්න යන්නේ. And if you are using that online simulation, then just you have to copy this program, Control A and Control C, like that we can copy, and we can paste that into the online environment. That's online environment. I will show that in first. Then within that online environment, there is some code. මෙතන පෙන්නන code කියලා icon එක. You can click on that. And then it will show the block diagram of that coding, but we are not writing that via the block. Like we can use the Scratch programming and same as the code programming. Then here I will explain code programming. Then you can click on that arrow in here, and you can click on the text. Text කියන mode එකට click කරන්න. Then it will go into the text mode. And there are some example code. Just you can delete it. You can delete කරන්න පුළුවන්, and you can copy and paste your code there. Then these are the code writing in Arduino, and I'm copying that and paste here. Just only that. And again, you can click on the code. Then it will remove. And after that, you can start simulation. You can click on the start simulation. Then it's working like that way. LED will light up. It's like that. We are write down only the light up code. Then according to that, it will light up. Okay, then I will show how to upload that into the real environment. Yeah, first we have to connect the board again to the USB port. Like that way. We can connect it. I will switch off the video, then it's clear, I think. You can see that other environment. No? Okay, no?
Yeah. They can see.
Yeah. Then next, it's okay. Then next, we can go to the tools and we can select the board again. Because of when you are removing that board from the physically, it will remove. Then again, you have to connect that board. And you have to connect that port also. Then it will mention many ports, but you have to select which one is the Arduino. Then you can select it and again you can upload that. Then no need to compile because of we already compiled. Directly you can upload.
Pin number is 6.
We have to change, no?
Physically connected to 6.
Pin number 6, we are connected to the pin number 6. Then we have to change that and again we have to upload it. Otherwise it will not work. Then LED will working like that. It will light up. Yeah, it's very simple. Yeah, any students or any teachers or anyone, if you have any questions, you can put in the chat box.
Continue. Then
If you have any questions, up to now, then you can put messages. And all of you are okay, then you can put some messages for the continuation because of we have to continue it. If you are successfully done, then you can put the message. Next, we will try to blink that LED like on and off. Then again, we can write down some code for switch off that LED. Same as this one, like a digital. Right. Then within brackets, we can write down pin number 6, comma, low. And again, we need to write down some delay. Like that. Then I will upload that into the board. Then I'm getting some error because of I forgot to write down semicolon there. Then you can see it will give some suggestions. Like before the delay, it will missing semicolon like that. Then you can see you can understand what's the error and you can type that. And again, you can upload. Yeah, it's uploaded. Then you can see when it is uploading, there are some LEDs will blinking when it is uploading time. An LED will blinking like that. 1 second switch off, 1 second switch on. Like that, it will blink.
300. If we put 300 milliseconds,
yeah,
we
then
can see the blinking faster.
We can change that delay. Like that, we can change. So 500. Any values you can put and you can upload it.
See the blinking speed will change.
Then quickly it will blink like that. We can change the blinking speed. If you need very fast, then you can reduce the time here and here. If you need long time, then you can put larger value there. That's a method you can use. When all of you are finished, then you can put some messages into the chat box. First, you can try it, and after that, put the message. Next, we are doing many programs, many examples there. You can see that quickly. If you are done that, then you can put some message. Then quickly we can move to the next part. Otherwise, without that delay, we can continue it.
We're having only 20 minutes more. So if you are okay with the codings up until now, you can say yes to continue. Just put a yes to chat box, then we can continue.
Yeah, otherwise we don't know if it is working or if you are getting some troubles. No. If you have any troubles, then you can put that also. Then we can help you. Then circuit connectivity is like that. You have to connect it like this way, via the software or via the hardware. Software පාවිච්චි කරන්නත් පුළුවන්, hardware use කරන්නත් පුළුවන්. Anyone. And program is like that. I think you can see hardware, circuit, and programming both.
Full code. I can show them the full code.
Yeah, this is a full code.
Last bracket.
Bracket also. That's a full code starting from void setup. Then this is the setup part. Then this is the loop part. If you need, I will put that full code into the chat box. Okay, you can get the full code.
හැමෝටම තේරුණාද? තේරුණා නම් yes එකක් දාන්න. එතකොට අපිට continue කරන්න පුළුවන්. අපි බලන් ඉන්නේ ඔයාලා මේ part එක වෙනකම් කරගත්තද කියලා දැනගන්නයි අවශ්‍ය. Yes.
Yes. Okay.
Others? Yes. Okay. Yes.
Yeah.
Okay, then we can
I think all are okay. Then we can continue. then you can remove that board and again connect. For the serial port error, remove your board from the USB and again connect it. Then it's working. Then next we will try to change their port. Then you are connected LED to the pin number 3 or any pin. Then after that we need to change that. For the pin number 4, how we change? Then you need to change that all the settings in here, here and here. Like within your program, you can see this is a program. Then pin number 6. Then we need to change that for pin number 4. Height connect karapu LED එක මට 4ට connect කරන්න ඕනේ. Then how we can do it? We have to change that all. Pin number 4, here also pin number 4, here also pin number 4. Like that we can change it.
Like here,
Yeah. Like that we can change that. Then same as the when you write down like that program, then it's very difficult now. Like that. Then you have to change here, you have to change here, and you have to change here also. Then 3 times you have to change. But there are some easy method. First you can list down that pin in here. Pin එක මුලින්ම අපිට මෙතන set up කරන්න පුළුවන්. Top of the void setup like that. Int LED equal pin number 4. Like that we can set up it. Pin number 4 එකට තමයි මම LED එක connect කරන්නේ. Like that. I will mention in top. Then after that, no need to change that everywhere. Then we can write down their name. Then we can give the name for that pin. Like that. I am replacing that all the pin numbers by the name. Just we are giving one of the name for that pin. Pin number 4 කියන එකට අපි නමක් දුන්නා. Like LED. Like that we can do it. It's very simple. Same code we are using, but little bit different. I will put that also into the chat box. Then you can copy and paste it. Then when you write down like that, it's very easy. We can connect a LED like that. We already connected that. Then next we will try to connect 2 LEDs to the breadboard. අපි LEDs දෙකක් connect කරලා program එකක් ලියලා බලමු. Like that. Then we can connect 2 LEDs on the breadboard. For the 2 pins, we can connect 2 LEDs to the 2 pins. I will show that on the 𝗕𝗥𝗗𝗏 website. And I am taking another LED with a different color, like a blue color. And we can connect that LED also into the same negative line, like that. We have to identify their negative side, and we can connect that LED to the same negative line. Then LED 1 connected like that way. LED 2 also we can connect like that way. දෙවෙනි LED එකත් අර විදිහටම අපි connect කරන්න පුළුවන්. Then before connecting that LED, you should remove the USB connection. USB port එකෙන් connection එක අයින් කරලා LED එක connect කරන්න. Otherwise, if it is short circuited, then it getting some troubles. Like that you can connect. And you can take the another resistor, same type. And you can connect second resistor also, same as previous one, like that. කලින් එක වගේම connect කරන්න from here to here. We are connected like that way, and we are connecting resistor like this way. Then negative side, we no need to connect again because of one of the wire we are connected already like that way. Then we can connect their positive side from here to the Arduino pin. By using connecting wire. We can use another connecting wire like that. And we can connect that into the next pin. Like a pin number 4. Pin number 3 and pin number 4. Like that we are connected 2 wires. Change their color like that. We can connect, we can use many color wires and we can connect like that way. That's the structure. Then 1 LED, 2 LED. Then ground side is common, 1 negative side, like that. So 1 wire. And 2 positive sides. Dana wire dekak tiyena, rina wire ekak tiyena, like that. Next, we can change the program. Then this is the hardware structure. Then we have to change the software structure also. Then there are 2 LEDs. Api LEDs dekak connect kala tiyenne. Then we can write down their name like a LED 1 and LED 2, like that way. LED 1, I'm giving one name. For the other LED, I'm giving LED 2, like that. Then without space, you have to type that. LED kala type kala space එකක් තියන්න එපා 1 කියලා. You have to write without space LED 1. Otherwise, you can use LED A, LED B. That's also okay. Any name you can use without space. LED 1 and 2 are easy, no? They can, because of that, I'm write down like that. Then LED 1 connected to the pin number 3. LED 2 connected to the pin number 4, like that. Then there are 2 things. Then same as the, you have to set up LED 2 also like output. Then LED 1 output, LED 2 output. Dekam output karanna ඕනේ. Like that. Next, we have to write down program for both LED. Then first we can switch on first LED. Then after some delay, we can switch on second LED, like that. Then LED 1 first switch on, after delay, we are switch on second LED, like that. Then again we take some delay. LED 1 switch on, they are taking some delay. Then LED 2 switch on, they are taking some delay. And LED 1 switch off. After that, we can switch off LED 2 also, like that. You copy same code, paste in here, in LED 2. Like that, you can change the LED working pattern. ඔයාලට කැමති විදියට pattern එක change කරන්න පුළුවන්. First it will light up LED 1, then light up LED 2, then switch off LED 1, switch off LED 2. Or otherwise, in same time, you can switch on, same time you can switch off. Like that, you can write down many patterns there. As a simple example, you can write down some like a color light program. In the color light, it will work in yellow color, green color, red color. Time to time it will switch on and off, no? Then you can write down like that. Then again, we can upload that. Then before the upload, we have to connect USB port again. And we can upload it. Pin number 3 and 4. Then if you need to change that pin number, then quickly you can change it. Then no need to change everywhere. That's the very easiest thing. If you are using number, then you have to change all the locations. That's very difficult now. Because of that, we can use this method. It's very easy. Then we can upload that code. First, we have to select the COM port and we can upload it. Yeah, uploaded. This one is not uploaded.
LED is not working. No?
Yeah, LED is not working. You can use the yellow color one. Yeah, like that. Then it will working like that. First LED light up, then after that second LED light up, then first one switch off, then second one switch off, like that. Okay, I will copy and paste that into the chat box. Everyone, you can copy and paste. You can try it. First, you can connect the circuit, and after that, you can upload your program like that way. And same as you can change the blinking pattern like that. First, LED 1 and LED 2 both are switch on. Then after that, taking some time, then LED 1 switch off. After some time, LED 2 light off. Like that, you can change the program. You can change the pattern. ඔයාලට කැමති විදිහට ප්‍රෝග්‍රෑම් එක වෙනස් කරන්න පුළුවන්. That is steps. මේ steps ටික වෙනස් කළාම ඒකට අනුව output එක ඔයාලට ගන්න පුළුවන්.
දෙකම එකපාර වත් වෙලා දෙකම එකපාර නෙවෙන්න හැදුවොත් කොහොමද?
Yeah, you can change like that. First, light up LED 1, then same as the LED 2. Then after taking some time, then connect switch off LED 1, LED 2.
Now you have to upload this.
Yeah, now you have to upload. Uploaded, then in the same time it will switch on and switch off. ඔයාලා මේ programming environment එකට familiar වුණාට පස්සේ it's very easy. You can write down many programs by using same code. Just only write down two codes now, pin mode and digital write. Two codings. This one is the one code, this one is the one code. Then same as you can connect more LEDs. You can connect more than 10 LEDs there because of many digital pins there. And you can write down different LED patterns. Like a one by one switch on, then one by one switch off, like that many different patterns you can write down.
Night rider code.
Yeah, it's like a night rider. This is one of the example. 1, 2, 3, 4. 4 LEDs there. Then it will light up one by one. LED eking එක on වෙනවා. And you can write down reverse order also. First this one light up, then second one, third one, fourth one. Again it will going back. And after that light up all in one. Then switch off all in one. Like that many patterns you can write down. Then this is one of the example for night rider. You can connect 1, 2, 3, 4, 5 LEDs and you can write down some programs.
You can read now.
Yeah.
That will be really interesting.
Then quickly we can do it. You can use same structure. I will show that.
I need some LEDs and
Yeah.
resistors.
Then there
That
is
one not
LED.
working.
You can use another LED here. And resistors also there. The important thing is when you are connecting, before connecting, you have to remove the USB connection. Otherwise, it will short circuit. And I will draw the circuit here.
You have to connect all the 5 LEDs as the same way we connected earlier. So I'm doing it physically.
You can use many different colors. Like that, different color LEDs you can use. And you need more resistors. Same type resistor, you can connect like that way. And then next side is a positive side. You can connect that all the positives according to some order. The first one 3, the second one 4. Next, next LED for the next line, number 5. Next one for the number 6. And next LED for number 7. Like that you can connect all. Then 3 to 7. 3, 4, 5, 6, 7. LED 1, 2, 3, 4, 5, 6. Then like that 5 LEDs you can connect. Next, I will show how to write down program. And LED 1, LED 2, LED 3, like that way we can write down program. Then 5 LEDs are there. Number 3, 4. Next one is the 5th. Then 6 and number 7. Then we have to set up that all as output. Then next we have to write down program. That's a very important part. How we light up LEDs. Then one by one we can light up. LED 1, LED 2, LED 3, next LED 4. Then we can write down a small delay in between that condition. Like that LED 1 light up, then 2 light up, 3, 4, and 5 also there. Number 5, like that according to this order it will light up. Then next we can write down switch off condition also. Then we have to change the LED numbers. Switch off one, LED 1, 2, 3. Then number 4. And last one is the number 5. Like that. That's the program. Then next we can connect the USB port and we can select it and we can upload.
Here I have connected it physically. 5 LEDs, 5 resistors and 5 jumping wires to digital port from 1 to 5 and 1 ground connection. You all can see it clearly, right? From 1 to 5 I connected. We have to change the pin also.
Here we can change it.
Here also physically we can change from 3 to 7 pin. We're doing it.
Yeah, like that.
We physically changes pin to digital pin from 3 to 7. So now start to blink.
Then we can reduce their timing. Then it's working quickly. Then we can write down same code in delay code also. We can repeat same one because of otherwise we have to change manually that all the thing.
You have to upload it again. So
Then it's quickly working.
Yeah.
Like that. Then you can write down their reverse pattern also, like a night rider.
yeah.
From this side to that side and that side to this side.
You can use maximum of 14 LEDs here, no? Because we're having 14 digital pin in this board.
In this side.
From 0 to 13.
If you are using mega board, then you can connect more than 50.
More than 50 LEDs.
And there are some hidden pins also. You can create more than 80 also there.
It's like game actually. You can create these all and show it to your friends and all because it's something really easy and interesting.
I will copy and paste that into the chat box. If you need, you can take it. You can change that printing pattern order and the delay, and you can get many different outputs according to that. And same as the quickly I will explain some other examples, but time limitation is over. Then next one is we can use some of the switches as input. Then when push button, click on the push button, then according to that we can switch on LEDs. First we can press the button. When we are pressing first time, first LED will light up. And after that, when you are pressing second time, second LED will light up. Then when you are pressing third time, you can switch on third LED. Like that, according to the input condition, we can set up the output. Like a fan controller. Normal fan is like that. No? There are some many conditions. We can use only one switch for that. That's one example. Input with output. The next one, like a analog input, we can use some of the LDR and we can connect there as an input. And according to that light intensity in your environment, we can write down like that way. What's the light intensity? Then according to that, the LED will light up. We can set up a light intensity. Then if it is going over, then it will light up. Like if it is there dark environment, then we can switch on some of the light. Like that, we can use LDR for detecting light intensity as input. That's for the analog sensor. The previous one, digital sensor, like LED, that switch. Then the same as we can connect some of the buzzer. Buzzer mean it's like that, very small speaker.
With sound.
Yeah, we can play some of the sound. There are some beep sound. I think all of you know, like a chumpang sound, like that music we can generate, like this. Then the keyword, there are some special keyword like a tone. Then happy birthday sound, like that tone we can generate by this method. I think there are some students, they are doing music, they know that frequency patterns. There are some letters now in the music, then we are playing that letters. And according to that letter, we can play some songs also.
One small question, sir. Why we are using resistors here? Because we can directly connect to the LED even.
Yeah. Then LED is working with 3 volt. That's the maximum voltage of the LED. But this board is digital board. They are providing 5 volt. Then if we are connecting LED directly to the 5 volt, LED will blast. Because of its working, maximum 3 or 3.5.
To protect the LED,
Yeah.
we need to use resistors.
Like that, I have explained it in here. Like we can use one of the resistor for protection. And like that, we can play some of the music also. These are some examples for playing some happy birthday song like this kind. Okay, I think you are getting some IoT related knowledge. Then, do you have any questions based on today we are done part?
ඔයාලට මොනවා හරි ප්‍රශ්න තියෙනවා නම් දැන් අහන්න පුළුවන් මේක ගැන. අපි දැන් සෙෂන් එක ඉවර කරන්න හදන්නේ. ඉතින් මේ වෙනකම් කරපු දේවල් වල මොනවා හරි ප්‍රශ්න තියෙනවා නම් ඔයාලට අහන්න පුළුවන්.
And same as we can do many more sessions for you.
මොනහරි ප්‍රශ්න තියෙනවා නම් ඔයාලට අහන්න පුළුවන්. If there are any question you can ask from us. Central College එකෙන් දාලා තියෙනවා digital write 3 high delay 1000. මොකක්ද නෑ ප්‍රශ්න.
Yeah, what's the problem with that? This code.
ඒ code එකනේ.
Yeah. Then first we are connected to many LEDs now. Then all the LEDs we are mentioned like LED 1, 2, 3 like that.
ඒ code එක අර part එක විතර
I think that's
කරලා හරිනේ simple.
The first one මේ තියෙන්නේ ඉතින් අපි LED 1 කියන එකක් connect කළා. LED 1 එක අපි connect කරන්නේ pin number 3 වලට. Arduino board එකේ. Then LED 2 එක connect කරන්නේ pin number 4 වලට. LED ඊළඟ LED connect කරන්නේ pin number 5. ඊළඟ එක pin number 6 වලට. මේ තියෙන්නේ real pin number එක. ඒ pin numbers වලට දීපු නම තමයි අපි මේ තියෙන්නේ. That's a name. Just name. Because of after that we have to use that name in here. ඒ name එක අපිට මේ code එකේ හැමතැනම use කරන්න වෙනවා. අපි මේ pin එක ගත්තා නම් ඒක ගොඩාක් තැන්වල අපිට repeat කරන්න වෙනවා. ඒ repeat කරන්න ගියාම numbers පැටලෙන නිසා තමයි මම මේ විදිහට නමක් දැම්මේ. Just name. LED 1. එතකොට අපි හැමතැනදීම හොයාගන්න පුළුවන් this LED 1. First LED. Then here LED 1. Here LED 1. Otherwise it will forget no. අපිට මේ board එකේ දැන් LED 1 කිව්වහම this is the first LED. අපිට පළවෙනි LED කියලා ගන්න පුළුවන්. හැබැයි මෙතන pin number 3 කියලා දැම්මනම් මෙතෙන්ට ආවට පස්සේ අපි දන්නේ pin number 3 කියන්නේ මොකක්ද කියලා. That's the problem. Then otherwise you can use direct number here. But there are some trouble. ඒක නිසා මේ විදිහට rename කරගත්තාම අපිට identify කරගන්න ලේසියි.
අපිට එතකොට මුළු කෝඩ් එකේම LED එකේ නම්බර් එක pin number එක එකපාර change කරන්න
පුළුවන්. මේ number එක වෙනුවට අපි මේ නම replace කරනවා.
නම තමයි දාලා තියෙන්නේ. එතකොට එයාගේ key එකක් විදිහට නම යනවා හැමතිස්සෙම. එතකොට මේ නම ඔයාලට කැමති නමක් දාගන්න පුළුවන් වුණාට. LED1 කියලාම දාන්න ඕනේ. So in කියන එක කෝඩ් එකේ තියෙනවා. ඒක ඔයාලට change කරන්න බෑ. equal sign එක සහ
int කියන්නේ it's a integer because of this number is like integer no? Decimal point is not there no? Because of that we are using integer.
So LED1 කියන එක LED2 LED3 ඒක ඔයාලට කැමති නම දාගන්න පුළුවන්. ඒක just a name. ඒක එතන දාපු එකම තමයි ඔයා continuously මුළු කෝඩ් එක පුරාම use කරන්න ඕනේ. තව මොනවාරි ප්‍රශ්න තියෙනවද? එහෙම නැත්නම් okay කියලා අපිට message එකක් දාන්න අපිට ඊට පස්සේ session එක end කරන්න පුළුවන්. okay කියලා message එකක් දාන්න ඔයාලට clear නම් automatic.
Yeah, if you need to contact me, then I can give the my number. So that's okay.
And then,
Yeah.
Deshapriya sirගේ අපිට Deshapriya sirගේ email address එක දෙන්න පුළුවන් මොනවා හරි ඔයාලට contact කරගන්න අවශ්‍ය නම් මේක සම්බන්ධව තියෙන අපි direct මිස් දේශාන් මෙතන ඉන්නවා පොඩක් ඔයාලට කතා කරේ චූටි වෙලාවක්. එතනදී අපි ඒ අතරතුර Deshapriya sirගේ details ටිකක් share කරන්නම් ඔයාලට සහ ඔයාලට further මොනවා හරි දැනගන්න ඕන නම් අවශ්‍ය කරන contact details උත් අපි share කරන්නම්. මිස් දේශාන්
That's the email address. You can use. You can send.
switch on the video.
Thank you. I think today would have been a very learning experience day for especially for a area like this, which is very important and upcoming, and it's mandatory for anybody who is in any stream. Learning IoT, I think, is very important. So I think you have had a very good experience in this regard and would have learned tremendously very important areas, and especially on the subject areas for your advanced level examination, advanced level curriculum. So I think we would want to do this in the future as frequent as possible. If you have any request for us to do, come to your school, your specific school, and do it physically or even online. We are open for it, because we are mainly our purpose is basically to share our knowledge with our students, and of course we are very keen to also see that there are so many students from international universities also joining us. So that shows how much interested this area is. So please let us know if you have any requests from your school. Please make sure that the requests come from the teacher in charge or the principal to us, even to this email address or the email address that I will share, as special requests coming from your schools to do further areas of this IoT and even any other related areas. We are willing to do that. අපි මේ areas වල වැඩිදුර programs කරන්න මම හිතන්නේ දුවල පුතාලගේ පාසල් වලටම ඇවිල්ලා physically කරන්නත් online කරන්නත් අපි කැමති. ඒ හින්දා ඒ වගේ අවශ්‍යතාවයල් තියෙනවා නම් අපිට යොමු කරන්න කියලා අපි ඉල්ලලා සිටිනවා. ඉතින් මම හිතන්නේ දැනටම request එනවා. ඉතින් අපි request ඔක්කොම සලකලා බලලා අපි අපිට ඇත්තටම මේ email address එකක් අපි දෙන්නම්. ඒ email address එකට පුළුවන් නම් teacher හරහා අපිට email එකක් එවන්න. අපි එතකොට ඒ request එක අපි අනිවාර්යෙන් මේ fulfill කරලා දෙන්නම් කියලා අපි කියන්න කැමතියි. කොහොමත් මේ ස්තුතිය අද සම්බන්ධ වුණාට මම හිතන්නේ අද හුඟක් අවශ්‍ය හුඟක් ඉතා වැදගත් දේවල් ටිකක් ඉගෙන ගත්තා කියලා මම බලාපොරොත්තු වෙනවා. බොහොම ස්තුතියි.
මම ඊළඟට දාන්න. Okay. chat box එකේ දාන්න තියෙනවා email address එක ඔයාලට samira@lnbti.lk කියන email address එක හරහා මේ සමීරට දාන්න පුළුවන් ඔයාලගේ ඉස්කෝලවලට ඇවිල්ලා IoT session එකක් කරන්න අවශ්‍ය නම් ඒ email address එකට ඉස්කෝලේ ගුරුවරු හරහා අපිට request එකක් දාන්න. එතකොට අපි ඔයාලගේ ඉස්කෝලේට ඇවිල්ලා මේ session එක මේ වගේ sessions මීට වඩා තව වැඩිපුර ඔයාලට දේවල් දැනගන්න අවශ්‍ය නම් මේ වගේ IoT related දේවල් සම්බන්ධව ඔයාලා අපිට රික්වෙස්ට් එකක් දාන්න අපි ඒ දේවල් arrange කරලා ඉස්සරහදී ඔයාලට ඒවා අපි ඔයාලගේ ඉස්කෝලේට ඇවිල්ලාම ඔයාලව හම්බ වෙන්නම්. ඒ වගේම for the international students thank you very much for joining with us for this valuable session. So hope you all got to learn a lot about Arduino IDE, Arduino boards and all the things. Thank you very much, Deshapriya sir, for all the information that you have shared with our students. Thank you very much.
Recording එක ගන්න කොහොමද කියලා අහලා තියෙනවා.
We will share the recording in YouTube channel. So follow our YouTube channel and we will share the link with you all via SMS. So thank you very much. අපේ FB page එක YouTube channel එක website එකේ එහෙම touch එකේ ඉන්න follow කරලා subscribe කරලා තියාගන්න YouTube channel එකේ එහෙම අපි එතනට upload කරනවා අපේ සියලුම recordings. So එතනදී ඔයාලට බලා ගන්න පුළුවන් මේකේ recording එක. Can we have lecture slides, please? අපිට lecture slides share කරන්න පුළුවන් නේද sir?
Yeah.
Yeah. School වල teachers ලා අපිට පොඩක් message එකක් දාන්න අපි දුන්න contacts වලට මේ email එකක් හරි දාන්න අපි lecture slides ටික share කරනවා.
මම copy කරලා දාන්න email address දෙකයි.
UMTC College students, thank you very much for your attending with our program. So drop me a WhatsApp message to +9477336000. You all can hear me, right? UMTC students, so drop me a WhatsApp message to +9477336000 for any further clarification. We are like glad to see all here. Actually, that's a great thing to see you all here. Thank you very much, UMTC College students. Deepthi Manjula, we will share the recordings in our YouTube channel. We will share a screenshot of our circuit to chat. So wait a second. If you all like, you can download it also. It's nothing to use. We will share a screenshot of the circuit.
Let's see how to save it. Save correct. That's fine.
It's not taking actually that screenshot, so we will share the PPT with you all. Okay, we will upload the PPT to a drive, and then we will share the drive link with you all. So there is a small problem to contact UMTC students, so they need to drop me a WhatsApp message in order to get the PPT. So others, we will share the PPT link with you all via SMS. Hope you all registered with the session Google Form. Thank you very much. Then we will end the session now.